Hey everyone, and welcome to The Explainer. Today, we're going to be detectives. We're putting on our detective hats to solve one of the biggest mysteries out there. What in the world makes the weather? And hey, by the end of this, you'll be a certified weather detective, spotting clues all around you. Okay, ready? Our first mystery is waiting. Let's get on the case.
So, every good mystery kicks off with a great question, right? Here's ours. Have you ever thought about this? How can you have a snowy mountain for skiing and a hot, sandy beach for swimming practically next to each other on the very same day? I mean, it seems totally impossible. Well, that's the exact case we're cracking today.
Okay, before we start hunting for clues, we need to get our vocabulary straight. First up, weather versus climate. Weather is all about the here and now. Is it sunny outside right now? Is it raining today? That's weather. Climate, though, is the bigger picture. It's the pattern over many, many years. You could say weather is your mood today, but climate is your whole personality. Make sense? Cool. Now that we know our terms, it's time to find our first clue.
Our first and, honestly, most important suspect is that giant, fiery ball in the sky. Yep, you got it, the sun. The sun is basically the engine that drives all the weather here on Earth. But how it does that, well, that's the key. See, the thing is, the Earth is a giant sphere, kind of like a basketball. And because it's curved, the sun's powerful energy doesn't hit every single part of it in the same way. Some places get a direct, powerful hit, while others just get a little glancing blow.
And this is absolutely crucial. Take a look at the equator, the Earth's belly band. The sun's rays smack right into it, straight on. It's like pointing a flashlight directly at something. You get a super bright, super strong beam of light. That means it gets really warm there. But way up at the North and South poles, those exact same rays come in at a steep angle, and the energy gets all spread out. It's like shining that same flashlight from way off to the side. The light is way weaker, and that one simple fact is the main reason the equator is hot and the poles are freezing.
But hold on a second. The sun's angle can't be the whole story. What about our original mystery? The ski mountain right next to a warm beach. That's where our second clue comes into play. The secret of the mountains.
Have you ever been driving up a tall mountain and felt your ears pop? That's because the air is getting thinner. There's literally less of it pushing down on you. And guess what? Thinner air just can't hold on to heat very well. So as you go up, up, up in altitude, the temperature goes down, down, down. For every 1,000 meters you climb, it gets about 6.5 degrees Celsius cooler.
Okay, now here is an absolutely amazing piece of evidence. Check this out. Mount Kilimanjaro is in Africa, right near that super hot equator we were just talking about. So based on our first clue, you'd think it would be scorching hot, right? But nope, because it's so incredibly tall, its peak is covered in snow all year round. This is the ultimate proof that altitude, how high up you are, can sometimes be an even bigger clue than where you are on the globe.
Man, this investigation is getting good. We've looked at the sky, we've looked at the mountains, but a huge part of our planet is covered in water. Our third clue is all about the epic tug-of-war between land and sea. Think about a hot day at the beach. The sand gets so hot it can burn your feet, but the ocean water stays pretty cool, right? That's because land heats up and cools down way, way faster than water does. And this creates two totally different kinds of climates. If you live near the ocean, you get what's called a maritime climate. The water acts like a giant temperature regulator, so it never gets crazy hot or crazy cold. But places far away from the sea, they get a continental climate, which means they get the extremes, super hot summers and freezing cold winters. And that's not all the ocean does. The oceans have these massive currents, which are like giant rivers flowing all around the world. They act like huge conveyor belts, carrying warm water from the equator up toward the poles and cold water from the poles back down. This is how the planet shares heat, warming up places that would be freezing and cooling down places that would be boiling. Okay, weather detectives, for our final clue, we need to look for things we can't even see. These are the invisible forces that are secretly pushing our weather around every single day.
First up is something called atmospheric pressure. I know, it sounds super complicated, but it's really just the weight of all the air pushing down on you. Here's all you need to remember. When air gets warm, it gets lighter and floats up. That creates an area of low pressure. When air is cool, it's heavy and it sinks, creating high pressure. So warm air means low pressure and cool air means high pressure. Simple as that.
So, what happens when you have some high pressure right next to some low pressure? Well, nature hates an empty space. All that cool, heavy air from the high pressure zone rushes in to fill the gap left by the rising warm air. And that rush, that movement, that's wind.
It's really that simple. Wind is just air moving from a high-pressure spot to a low-pressure spot. And our last invisible clue is humidity. It's just a fancy word for how much water vapor is floating around in the air. You can't see it, but you can definitely feel it. You know those really sticky, muggy days where you feel like you're walking through soup? That's a high humidity day, and it feels extra warm because all that moisture in the air makes it harder for your sweat to do its job and cool you down.
So there we have it. We've gathered all the evidence. We've looked at the sun, the mountains, the oceans, and even the invisible forces. I think the case is ready to be closed. Let's lay out all the clues and solve this weather puzzle once and for all.
So it turns out the weather you're feeling right now, just outside your window, isn't caused by just one single thing. No way. It's like a giant recipe. It's a mix of the sun's angle where you live, how high up you are, how close you are to a big ocean, and that invisible dance of air pressure and wind that's happening all around you. All of these clues work together to create your unique weather every single day.
So the mystery is solved. But I've got one last assignment for you. Look outside. Think about where you live. Are you near the ocean? Are there big mountains nearby? Are your summers crazy hot and your winters crazy cold? Now that you're an official weather detective, what do you think is the biggest, most important clue that makes the weather where you live? The investigation continues. Thanks for joining me on The Explainer.